Good day friends, welcome to my channel lecture series in power electronics. In this session, we'll solve a problem in which the resistors are connected in parallel. In this example, a battery with a terminal voltage of 3 volts is connected in parallel with 3 resistors, 2 resistors having a value of 2 ohms and 1 resistor having a value of 1 ohm. It is required to calculate the equivalent resistance of the circuit, calculate the current through the circuit, the current through each resistor, the total power dissipated by the resistors, and the power supplied by the battery. The formula for calculating the equivalent resistance of a parallel circuit is given by 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus and so on up to 1 by Rn. In this particular case, we have 3 resistors. So the equivalent value 1 by R equivalent is equal to 1 by 1 plus 1 by 2 plus 1 by 2, which is equivalent to 4 by 2. And the 1 by R equivalent is 2 ohms. We want the value R equivalent, which is the reciprocal of this. So R equivalent will be 1 by 2, which is 0.5 ohms. The equivalent resistance in the circuit is 0.5 ohms. The current through the parallel circuit can be calculated using the Ohm's law. Current I is equal to V by R equivalent, which is 3 by 0.5 ohms is the R equivalent value. 3 is the voltage. So the current in the circuit is 6 ampere. The current through each resistor is calculated by the supply voltage divided by the value of the resistance. So the current through the 1 ohm resistor is given by 3 divided by 1, which is 3 ampere. Current through the 2 ohms resistor is given by 3 by 2, which is 1.5 ampere. And the other resistance is also having the same value of 2 ohms. So through that also a current of 1.5 ampere flows. So the 6 ampere current in the circuit is distributed as 3, 1.5 and 1.5 ampere based on the value of the resistances connected in parallel. The total power dissipated by the resistors is given by the formula P is equal to I square into R equivalent. The current in the circuit is 6 ampere. The equivalent value of the resistance is 0.5 ohms. So the total power dissipated by the resistors is equal to 18 watts. It can be calculated as P is equal to V into I also. Voltage in the circuit is 3 volts and the current through the entire circuit is 6 ampere. The power dissipated by the resistors is given by 3 into 6, 18 watts. The power dissipated by each resistor can be calculated as P is equal to V square by R. The power dissipated by a resistor of 1 ohm value is 3 square by 1, where 3 is the supply voltage, which is 9 watts. And the power dissipated by the other two resistors, which are of 2 ohms value, is 3 square by 2, which is 4.5 watts, 4.5 watts. So the total power dissipated in the circuit is 18 watts, which is distributed among the 3 resistors as 9 watts, 4.5 and 4.5. The power supplied by the battery is the sum of the power dissipated by each resistor. So we have already calculated the power dissipated by each resistor as 9 watts, 4.5 watts and 4.5 watts. The total power supplied by the battery is equal to the sum of the power dissipated by the resistors, which is equivalent to 18 watts. In this session, we have learned to solve a problem in which the resistors are connected in parallel. We have been able to calculate the current through each resistor and the power supplied by the battery. Thank you.